So regarding data centers, right now, most of them are using what kind of transceivers?
If we're talking about 100G transmission, our sales report still shows that the most frequently chosen transceiver is QSFP28CWDM4.
Why?
This is 100G transceiver, which is really cost effective comparing to LR4 transceiver. The price is almost half of the other version, but from data center points of view, it's good enough because it's covered the distance up to 2-3 kilometers. So it's perfectly address the needs of data center in terms of the distance, and it's half price of the other transceiver.
Answering your question, one of the main reasons is the kind of laser used in this transceiver.
Or kinds of lasers?
CWDM laser, especially with such range like Marcin mentioned, 2 kilometers, is significantly cheaper than laser used in 10 kilometers transceiver.
But it's actually not one laser, right?
Yes, we are talking about 4 data paths, 4 lasers multiplexed to one fiber at the emitter side and transceiver side.
So we actually have like the 4 optical signals coming out of the CWDM transceiver, right? 4 lambdas.
Yeah, this is exactly how the QSFP28CWDM4 works. But in fact, today, especially when talking about sustainability, we need to think a bit further, because what we see, the 400G transmission is coming to the data center today. And maybe the QSFP28CWDM4 is cost effective in terms of the purchasing, but it needs to be very quickly switched to another type of transceiver, which will be able to work together with 400G transceiver in the pair. So this is something I think it needs to be strongly considered by data center operators.
Some says that especially in data centers, density is king. Is this why the 400G ports?
Yeah, it's true, because one unit of switch is able to consist of 24, 32 ports, and there is no unlimited space for placing the ports.
Usually 42.
Yeah, so in case of aggregation of the connections, is very important how much servers we are able to connect to such a switch. So aggregation of 4 100G transmission into 400G port, or in near future 800G port, is exactly what you mentioned. We can aggregate much more connections to the single servers than number of ports we are able to use.
So we actually, in data center, we want to utilize as much to be used by servers rather than switches or networking devices, right?
Exactly.
This is one of the points, and this really needs to be considered by the data center operators, that instead of using CWDM4 transceiver, it's a high time to change to using the single lambda transceiver with the similar distance. There is one which is also able to cover 2 kilometers, which is called FR1, and this transceiver is already much cheaper than LR4. It's a bit higher than CWDM4 in terms of price, but the great advantages of this transceiver are that it could be directly connected to 400G transceiver on the other port. So the first step of migration to 400G technology will still need for us to connect 100G devices to 400G devices and then stack few 400G devices to each other. So investing in FR1 could save the cost of investment in long term.
So in terms of the sustainability that we mentioned, it makes the current purchase of the FR1 transceivers more future-proof, because they can either work with 100G aggregator switches and 400G aggregation switches, right?
Right. What's more, the 800G transceiver will use on the line side exactly same modulation and optical signal which today is used in the FR1 100G transceiver. So it means that the future proof is not only for migration to 400G, but is also capable to connect to 800G transceiver. Also, what we've noticed from the top chip vendor, the first samples of 1.6 terabit transceiver chipset, they will also contain 16 optical lanes, each with 100 gigabit speed. So it seems that using the FR1 will be not only today's 400G generation, but it also will be able to use together with 800G and 1.6 tera transceiver in the future.
The name we used here, single lambda, means in comparison to CWDM4 QSFP28 transceiver we mentioned previously, is related to one laser used in such type of transceiver. So it's easy to connect single lambda 100G transceiver with QSFP-DD 400 or future 800G transceiver, condensing the through output on the port of the switch.
Can we say in simple words, how will FR1 cooperate with the 400G transceiver? How physically will it cooperate?
Physically, we are using the special type of cable, which is on one side and with LC connector for 100G transceiver, and on the other side it has MPO connector for QSFP-DD 400G transceiver. So we are able to connect 4 lasers, 4 lambdas on 400G transceiver with single lambda on the 100G transceiver.
But still in 400G switch, these are 4 logical separate transmissions. Right?
Yeah.
So that's about sustainability in a data center. Invest in FR1 transceivers that will work for a long time, utilizing the newest technology of transceivers for many years upwards.